Hi, and welcome to the world of computer networks, where we'll talk about protocol layers concept, so let's start with the outcomes. Upon the end of this session, the learner will be able to understand what is the Internet protocol layers and what is encapsulation. Let's start with an example. Imagine if someone asked you to describe the airline system. How would you describe this complex system that has ticketing agents, baggage checkers, gate personnel, pilots, air traffic control, and a worldwide system for routing airplanes? One way to describe the system may be to describe the series of actions you take or others take for you when you fly on an airline. You purchase your ticket, check your bags, go to the gate and maybe get loaded onto the plane takes off and is routed to its destination. After the plane lands, you deplane at the gate and claim your bags. If the trip was bad, you complain about the flight to the ticket agent. We can divide the airline functionality into layers, providing a framework in which we can discuss airline travel. Each layer combined with the layers below it implements some functionality or some service. For example, at the baggage layer and below, baggage check to baggage claim transfer of a person and bags is accomplished. The other layer acts the same. Each layer provides its service by first performing some actions within that layer and second by using the services of the layer below it. Let's come back to network protocols. The protocols are organized into layers. Each layer belongs to one of the layers. When taken together, the protocols of all layers are called protocol stack. The Internet protocol stack consists of 5 layers: the physical, link, network, transport, and application layer. The Internet's application layer includes many protocols, such as HTTP protocol for web document request and transfer, SMTP for the transfer of email messages, FTP for the transfer of file between two end systems, and DNS for the translation of human-friendly names to a network address. At the level of the application layer, a packet is called a message. The transport layer transports application layer messages between application endpoints. In the Internet, there are 2 transport protocols, TCP and UDP. TCP provides a connection-oriented service to its applications. This service includes guaranteed delivery of messages to destination, flow control, and congestion control mechanisms. The UDP protocol provides a connection-less service and provides no reliability, no flow control, and no congestion control. At the level of transport layer, a packet is called a segment. The network layer provides the service of delivering the segment to the transport layer in the destination host. The Internet's network layer includes the famous IP protocol, which defines how end systems and routers act regarding to packets. There is only one IP protocol, and all Internet components that have a network layer must run the IP protocol. The network layer contains many routing protocols that determine the routes between sources and destinations. At the level of network layer, a packet is called a datagram. The services provided by the link layer depend on the specific link layer protocol that is used over the link. We can find Ethernet, Wi-Fi, and DOCSIS protocols. In the link layer, a packet is called a frame. Finally, we come to the physical layer. While the job of the link layer is to move entire frames from one network element to another network element, the job of the physical layer is to move the individual bytes within the frame from one node to the next. The protocols in this layer are again link dependent. Let's now see a complete example of how communication using protocol layers is done. Consider that a computer A wants to send a packet to computer B through a link layer switch and a router. The 2 computers implement all the Internet protocol stack. Routers and link layer switches organize their networking hardware and software into layers, but they do not implement all of the layers in the protocol stack. The link layer switches implements layers 1 and 2, and routers implements layers 1, 2, and 3. At the sending host, an application layer message that we call M is passed to the transport layer. The transport layer takes the message and appends additional information called header information that will be used by the receiver side transport layer. The application layer message and transport layer header information together forms the transport layer segment. The transport layer then passes the segment to the network layer, which adds header information such as source and destination and system addresses, creating a network layer datagram. The datagram is then passed to the link layer, which will add, of course, its own header information and creates a link layer frame. Finally, the physical layer will treat the frame as individual bytes. At the switch level, the frame is analyzed and then sent to the output port. The same is done in the next step, where the router analyzes the datagram and the packet is sent to the destination. From down to top, each layer at the destination host extracts the packet, and at the end, the application layer receives the original message. This is a simple example of how a packet is transmitted in a computer network. That is, guys, thanks for watching and see you in another video.